Factoring trinomials of the form x squared plus bx plus c. So this is a quadratic polynomial in one variable x. And this is also a trinomial. And the general form is ax squared plus bx plus c. And we see that the coefficient of x squared in our case is 1. In this case, when the coefficient of x squared is 1, this trinomial is called monic. Now, when we factor in a trinomial like this, okay, a quadratic polynomial, we assume that b and c are integers because not all the time we can factor a trinomial, a quadratic polynomial. Sometimes we need complex numbers in order to factor it. But for now we are working with real numbers and we are trying to factor this trinomial using real numbers. Now, how to factor a trinomial of this form? Let's go back to multiplication. We know that let's multiply x plus a and x plus b. So we know how to multiply. We multiply x with the second binomial and then a with the second binomial. So let's distribute the two terms of the first quantity. So x times x is x squared. X times b is bx. A times x is ax. And a times b is ab. And now we are going and combine like terms. Bx and ax are like terms, so we have x squared plus, when we combine like terms, we work with coefficient, and the coefficient are b and a, so a plus b, or b plus a, doesn't matter, x plus ab. So when we multiply two binomials in this form, x plus a, x plus b, where a and b are real numbers, we find a trinomial, a quadratic one, x squared plus a plus bx plus ab. So this is exactly this quadratic polynomial that we are working. So we have x squared. This a plus b is the coefficient of x, which is a sum, and it is b. And ab is a product and correspond to c. So ab is c, a product of a and b, and a plus b is a sum, which corresponds to b, and it is, so b is the sum of a and b. Okay, so now if we go back to factor this trinomial, we will get back two binomials, x plus a, x plus b. So let me write down. So to factor now a quadratic polynomial in this form, x squared plus bx plus c, we factor x times a number plus a number times x plus another number. So x plus a times x plus b. What we know about a and b? We know that if we multiply a and b together, we get c. And if we add a and b together, we get b. So b is the sum of those two numbers, a and b, and c is the product of those two numbers. That's it. So if we have a trinomial, we write x because x times x is x squared, and we saw here. And then we are looking to find two numbers that multiply together, give us the constant, and adding up together give us the coefficient of x. Now, what are the possibilities for a and b? Now, if a and b are both positive, this will give us a product c, which is positive. Or we'll write x c is greater than 0. Now, if a and b both are negative, still that will give us a positive product. If a and b are different sign, one plus and one minus, then this will give us a negative c. So c less than 0. Okay, so these are the possibility of the product. If we multiply those two numbers, maybe they are both positive, c will be positive. And if the c is positive, when we adding to positive, b will be positive. So let me write here. If c is positive, then b maybe is positive or maybe is negative. Okay, why? Because if we multiply to positive, we get a c positive, and if we multiply to negatives, we get a c negative. But when we add to positive, b is positive, and when we add to negatives, b is negative. Okay, so if the product is greater than 0, is positive, then the coefficient of x maybe is positive if both numbers a and b are positive, or maybe is negative if a and b are both negative. So, and if those two numbers have different sign, one is positive and one is negative, then c is less than 0, is negative. Now, if c is less than 0, then b must be positive if the largest is positive, and negative if the largest is negative. Okay, but we'll see this during the work. Let's go and work in some examples. Let's factor the following trinomials, which are quadratic polynomials. Okay? Now, let me write here. If I factor x squared plus bx plus c, I will get x plus a times x plus b. I know now. So immediately I will write x because x times x is x squared, and now I'm looking to find those two numbers a and b. If I am able to find those numbers, then I say that this trinomial is factorable. If I am not able to find those two numbers, then the trinomial is not factored by real numbers. Now, those two numbers has two conditions. Multiply together will give me the product 4. And adding up together will give me the sum 5. Now let's see. The product c is positive. So we have two possibilities. Maybe both numbers are positive. Multiplying to positive, you get a product that is positive. Or maybe both numbers are negative, because multiplying to negatives, we get a product that is positive. But the sum is telling us those two numbers are both positive, because if you add to positive, you get two positive numbers. So let me write the sign. Positive times positive is positive. Positive plus positive is positive. Now, what are the numbers? So I know that 4 is 4 times 1. And 4 plus 1 is 5. Now, 4 is 2 times 2 also, but 2 plus 2 is 4. So those numbers are 4 and 1. Since the signs are the same, maybe I want to write 4 here and 1 here, or 1 here and 4 here. It doesn't matter. And if we check, if we multiply those two binomials, we'll get back the trinomial. Now let's check. Positive 1 times positive 4 is positive 4. And positive 1 adding to positive 4 is positive 5. That's it. Correct. Let's go to the second. So x times x is x squared. Okay, I am looking for two numbers. When those numbers multiply, gives me 10, and 10 is positive. Since 10 is positive, this is telling me we have the same sign of the numbers. And the sum is telling us both numbers are negative. So, negative times negative is positive, negative plus negative is negative. So again, the product tells us, since it's positive, the signs are the same. Maybe both numbers are positive, or maybe both numbers are negative, but the sum is telling us both numbers are negative because you add up negatives together, you get a negative sum. So now 10 is 10 times 1. But 10 plus 1 is 11, is not 7. So 10 is 5 times 2, and 5 times plus 2 is 7. So these numbers are both negative numbers, and I write here 5 here, 2 here, it doesn't matter. Maybe you write 2 here and 5 here, it doesn't matter. So again, when the product is positive, we have two possibilities. Maybe both numbers are positive or maybe are negative, but the sum is telling us the exact sign. Now let's go here. X squared plus x minus 12, factoring as x times x, and now looking for those two numbers which multiply together will give me a negative product, which means that when I multiply two numbers and get a negative product, numbers have different sign. Because only if I multiply one positive and one negative, I get a negative product. No other way. And now, the sum, if I add those two numbers, which I cannot add but I will subtract from the largest and keep the sign of the largest. Why the largest is positive? Because the sum is positive. So, when I add those two numbers, which means I will subtract, this will be the highest number, the largest number, to give me a result that is positive. Now 12. 12 is 12 times 1. But 12 minus 1 is 11, so it doesn't work. 12 is 4 times 3. 4 minus 3 is 1. So 4 must be positive and 3 will be negative. Because 4 and negative 3 is positive 1. So 4 times negative 3, negative 12. 4 and negative 3 is positive 1. So if you choose negative 4 and positive 3, then what happens? If I write here positive 3 and here negative 4, positive 3 times negative 4 satisfies the constant, but positive 3 and negative 4 is negative 1. It doesn't satisfy the sum or the coefficient of x. Okay, so 12 is 6 times 2, but I got the right numbers that I needed. Done. So let's go to example 4, x squared minus 14x minus 72. So I want to factor. X times x is x squared. Now I need two numbers which multiply together give me negative 72, a negative product. Immediately I write one positive, the other negative. It doesn't matter. You can write here negative and here positive. It doesn't matter. What it matters that the largest will be negative. Because when we subtract, we keep the sign of the largest. So here will be the largest. In this case, the largest will be positive. In this case, the largest will be negative. Okay, so the product is telling us one is negative, the other positive. And the sum is telling us the sign of the largest. So, what is 72? 72 is 72 times 1, but 72 minus 1 is 71, doesn't work, it's not 14. So 72 is 36 times 2, but 36 minus 2 is 34, is not 14, it doesn't work. So 72 is 18 times 4, 18 times 4 minus 4 is 14, so I found the number. The largest will be negative and the smallest will be positive. Let's check. Negative 18 times 4 is negative 72, and negative 18 and positive 4 is negative 14. Correct. Now, before I go to other examples, let's go over again. If the product is positive, we have two possibilities for two numbers to multiply and to give us a positive product. Both positive or both negative. But the sum is telling us both positive. So the product tell us the sign are the same, and the sum is telling us exactly what is the sign. A positive product tells us same sign. This is telling us both negative. A negative product tells us different sign. The coefficient of x tells us the largest, okay, which will be positive. A negative product tells us different sign, and the sum is telling us the largest will be negative. Let's go and make some more examples. Now let's see in example 5, we see 2x squared plus 20x plus 42, which is not our form, x squared plus bx plus c, but we have a GCF here. We have a common factor here. And the GCF is 2 because 2, 20, and 42 are divisible by 2. So first I have to factor 2, which is the greatest common factor, open a parenthesis and write what is left. X squared, 20 divided by 2, 10, x, 42 divided by 2, 21. And now I have the form that I want. And I am continuing to factor. And I'm looking for two numbers now. Multiplying together will give me positive 21. And a positive product is telling me same sign. And the sum is telling us both positive. Positive times positive is positive. Positive plus positive is a positive. So now 21, the product, is 21 times 1. By 21 and 1 is 22. Doesn't work. 21 is 7 times 3, and 7 plus 3 is 10. So those two numbers are positive 7 and positive 3. Check. Positive 7 times positive 3 is positive 21. Positive 7 and positive 3 is positive 10. Done. So when we have a greatest common factor, okay, we have to factor it out first and then factor the trinomial. In this case, we have three factors. This is GCF, and these are two binomials that come from factoring the trinomial. Now let's go to example 6. We have x squared plus 3xy minus 28y squared. Now, we see another variable here, okay? But this equation is a quadratic polynomial in one variable x. So we consider y as a number, a fixed number, okay? But I need to rewrite this in terms of x. So exactly this form, when the variable is x. So I have x squared, I write 3 times y times x, and I know when we multiply, the order in multiplication doesn't matter. And now, let me put this, because this is the sum now, 3y minus 28y squared. So in other words, I have x squared plus bx plus c, where c is negative 28y squared, and b is 3y positive. Okay? Now I know how to factor. I have the first term x squared. And now let me write c here. So the product is negative, means that the signs of those two numbers are different. So one is positive, the other is negative. Now, since I have y squared, that means that those two numbers have y. So y times y is y squared. And now I want to break down 28. 28 is 28 times 1. By 28 minus 1 is 27. It doesn't work. 28 is 7 times 4. And 7 minus 4 is 3. Okay, so I have 7y, 4y. Multiplying this together will give me negative 28. The largest will be positive, so I have positive 7y and negative 4y squared. So positive 7y times negative 4y is negative 28y squared. And positive 7y and negative 4y is 3y. So correct. Let me put them. 7y here and 4y here. And check. Again, we did this here, but let's do it here. So 7y times negative 4y is negative 28y squared. 7y and negative 4y is positive 3y. Correct. Now example 7. When we read example 7, we have x to the fourth minus 26x squared plus 25. This is not a quadratic polynomial on the form x squared plus bx plus c, because the highest exponent is 4. But when we look at x squared, we know that x squared, if x squared is raised to the second power, then we have x to the fourth. So x is raised to the second power and you get x squared. X squared raised to the second power, we get back x to the fourth, which means that we can transform this 4-degree polynomial into a 2-degree polynomial. How? By rewriting this. Let me rewrite. So I will write x squared to the second power, which is x to the fourth. 2 times 2 is 4. And I will write this 26x squared plus 25. And now, if I leave t to be x squared, okay, I'm substituting t with x squared. So instead of x squared, I will write t, and I am writing now t squared minus 26t plus 25. And now we transform a 4-degree polynomial into a 2nd-degree polynomial, which we know how to work. So t times t is t squared. Now I need two numbers to multiply together to give me positive 25 and add up together to give me negative 26. So positive 25 means both numbers have the same sign, and negative 26 is telling us both are negative. Because negative times negative is positive, negative plus negative is negative. Now, what are those two numbers? 25 will tell us. 25 is 25 times 1, but 25 plus 1 is 26, so this is correct. So 25 is 5 times 5 also, but 5 plus 5 is 10, is not 26, so we got the numbers. We don't. It doesn't matter when I write here 25 here, it doesn't matter. And now I didn't finish because I have to replace t with x squared because my original equation is in terms of x and not in terms of t. This is the last job to substitute x squared now for t. X squared minus 1, x squared minus 25. So, done. Now, with the knowledge that we have, we are stopping here. And we said that we factor this x to the fourth minus 26x squared plus 25 into two binomials, two factors. Okay? Now, when we learn how to factor a difference of the squares, we have to continue. Because this binomial, both of them, are special binomials, and we call them the difference of two squares. So we have a difference of two squares, x squared minus 1 squared. A difference of 2 squared, x squared minus 5 squared. Now, for now, we don't have the knowledge and how to factor a difference of 2 squared, but later, in the after 2 lessons, we learn how to factor a difference of the squares like this, and we will continue to factor, to finish, to factor this trinomial completely. Okay? But for this, we are done. Now let's see example 8. We have x squared plus x plus 2. So I will factor this x times x. I need two numbers now. And I see that the product is positive and the sum is positive. So both numbers are positive. Now, what are those two numbers? For this, we have to check 2. 2 is 2 times 1 only. Now, those two numbers can be only 2 and 1. Okay? But 2 times 1 is 2, but 2 plus 1 is 3 is not 1. So 2 and 1, the factors of 2, are satisfying the product, but not the sum. Okay? That's it. So what does it mean? We cannot find two numbers in real numbers. Okay? We cannot find two real numbers in order to place them here. And those numbers to multiply together and to give us 2 and adding up together to give us 1. So this quadratic polynomial is not factorable into real numbers. You will learn later how to factor this by using complex numbers, but not in this course. So in this course, we are done. We factor using real numbers, okay? So that's it. So this was the lesson, how to factor a trinomial, which is a quadratic polynomial in the form x squared plus bx plus c. So in the next video, we are going to factor another form, ax squared plus bx plus c, when a is not 1. So here a was 1. For this reason, we didn't write it. And to the next video, we'll learn how to factor a trinomial like this, okay? Which is almost the same, but a little bit different. So see you on the next video. Thank you very much for watching my videos and listening my videos too. Thank you.